Assignment 2.2 steady state exercise draft. So, this is my hypothesis. For the cardiovascular response, I predict that the heart rate will plateau after 3 minutes of steady state exercise. For the respiratory response, I predict that the breathing rate will plateau after 3 minutes of steady state exercise until the end. And for the energy system response, I believe that the main energy system that will be used is the aerobic energy system. So this is how I conducted the tests. So before, what I'll be doing is I'll be attaching a heart rate monitor below the chest, and I'll make sure that the watch is working in unison. I'll take the weight of the person. I'll do this so that the correct resistance is put on the bike, so they're not pedaling against they're pedaling against some force. I'll take all of the tests on the performer, so the heart rate, the breathing rate, blood lactate, and O2 saturation, and I'll ask them to get on the practice bike and pedal for 5 minutes because this is their warm up and it stimulates the muscles that are going to be used, so they aren't going to go on and hurt themselves. After the warm up, the athlete will begin to pedal. So the heart rate method. I'll be taking the heart rate every 2 minutes. This is because it gives an accurate table of results and allows me to see if an anomaly has occurred. If an anomaly occurs, then I can identify and explain about it. I'll be using a heart rate monitor to do this by taking the readings, and the test will begin at 2 minutes, and I'll take a reading every 2 minutes after that. So for the respiratory rate, my method is I'll be measuring the respiratory rate every odd 2 minutes. This is because it gives a wider range of results and I can see that a plateau has occurred and also if there was an anomaly. I'll be watching the person's chest movements to measure the breathing rate, and once the test begins, I'll measure the respiratory rate at 1 minute, then 2 minutes every after that. So 1 minute, 3 minutes, 5 minutes, etc. For the blood lactate, I'll be recording this at five different intervals throughout the whole 20 minutes of steady state exercise. This is because I can easily identify what energy system is being used at the different times. To measure blood lactate, I'll use a blood lactate measurer to see how much lactic acid in the blood. This will be taken by a small pinprick on the finger, and then a reading comes out of the machine. Blood lactate will be taken at 2 minutes, 5 minutes, 10 minutes, 15 minutes, and 20 minutes. This is done so that I can see what time what system was being used at. So for the O2 saturation, I'll be measuring the amount of oxygen that's in the body, and I'll be doing this every 4 minutes. Again, this is to see what energy system is being used. To measure the O2 saturation, I'll be using an oximeter. This will be done every 4 minutes and will begin after exercise starts. After steady state exercise is finished, I'll make sure that the client steadily pedals because it is their cool down and is essential because the muscles need it. And if the muscles aren't being cooled down, then an injury can occur. My cardiovascular responses are heart rate. As I said, I predict that the heart rate will plateau after roughly 3 minutes of steady state exercise. During steady state exercise, the heart rate will increase at the start. This is because whenever you are beginning to do something, your heart rate is always going to increase due to the amount of oxygen that's required. This would then plateau towards the middle stages of exercise because you'll be working aerobically, so the body has surplus oxygen. And a quote from Prezi is that during an extended period of time performing steady state exercise, particularly in a hot climate, a steady heart rate will gradually increase. And I got this information from the website of Prezi. Stroke volume. I predict that the stroke volume will increase and then plateau during steady state exercise. Stroke volume will also increase during steady state exercise. This is because the heart is going to have to beat harder, which means more blood is going to be leaving the heart and be required by the working muscles. This should then plateau towards the middle stages of the exercise because the demand for blood should be equal with the level of intensity of the exercise. Cardiac output. I believe the cardiac output will increase and then plateau during steady state exercise. I believe it will increase from minute 3, and then plateau off of that until minute 20, and then steadily decrease afterwards. Cardiac output increases during steady state exercise because the heart rate has increased, and because of the increase in the heart rate, there's more blood that's going to be needed to be pumped around the body. So the cardiac output would then obviously have to increase because the requirement for the amount of blood pumped is going to be higher. But the cardiac output should plateau during the middle phase of the exercise because, again, the intensity is the same as the requirement. Blood flow. I predict that the blood flow would increase during steady state exercise and then plateau towards the middle stages. The body has many organs that it regards as crucial, and while at rest, these get the majority of the blood. This is because it is required to keep them going. However, during steady state exercise, the working muscles begin to receive more blood. This is because they need the oxygen to keep them moving and working. The blood is mostly sent to the muscles in the legs when you're going for a run, for example, because the hamstrings and the quadriceps are working harder and harder, whereas your bicep and your tricep and your arm are not. I've used the example as a run here because a jog is usually regarded as an example of steady state exercise, because you would be working at 50 to 70% of your heart rate, which is in an aerobic training zone. Blood pressure. I predict that the blood pressure during steady state exercise is that it will increase and then plateau. However, I am talking about the systolic phase here. Within the systolic phase, the blood pressure would increase and plateau. However, the diastolic should remain the same or could even decrease. This is because the diastolic phase is when the blood is filling the heart. And when the blood is filling the heart, when the heart is beating so fast due to the exercise, there isn't as much time for the heart to fill. Blood pressure increases during steady state exercise because there's more blood that needs to be sent around the body. So here I'm talking about the systolic phase where the blood is being pumped around the body compared to the diastolic, which is the filling stage. It's sent at high pressure to enable the working muscles to move and help the person move. When you're in the middle stage of the exercise, blood pressure should plateau. Again, I'm talking about the systolic phase here. This is because the heart rate would have hit a constant number and there wouldn't be as much blood needed to be sent around the body because the intensity would be exactly the same as the quantity needed. So, venous return. I believe that there would be an increase in venous return during steady state exercise. There would be an increase in venous return because of the heart beating more. This means that more blood is being sent out, so more would be required back from the working muscles. This happens due to the skeletal muscle pump, and the skeletal muscle pump is where muscles contract to force blood up through veins. And also there'd be an increase in oxygenated blood from the working muscles, so the heart would have to send more blood to the lungs and receive more back to pump it around. Starling's law. I predict that Starling's law would begin to increase while steady state exercise is occurring. Starling's law is where increasing filling pressure stretches the heart and increases the force of the contraction. So increasing the force of contraction expels more blood from the left ventricle. The cardiac output increases. However, this would need to increase during steady state exercise because more blood is going to have to be pumped around. So the heart is going to have to fill and contract faster. The respiratory responses. I believe that tidal volume would increase during steady state exercise. Tidal volume would increase because more oxygen is required by the working muscles. This means that you'd subsequently breathe more. Tidal volume would plateau during the middle stage of exercise because there'd be enough oxygen for you to supply the working muscles with. Breathing rate. I think that the breathing rate of a performer would increase during steady state exercise. The breathing rate would increase. This is due to the requirement for oxygen by the working muscles. They need oxygen to help them move. Also, there'd be a demand in oxygen because the body would also need it due to the fact it has just partaken in exercise. The effects of pH and temperature on the oxygen desiccation curve. I think that during steady state exercise, there'd be a large effect upon this. The pH of something would have an impact on the oxygen desiccation curve because it would move to the left. This means that there'd be a high saturation of hemoglobin in the blood. A change in temperature sees the curve move to the right. This means that less oxyhemoglobin is in the blood. And hemoglobin is what carries the red blood cells around in the body. Neuromuscular. During steady state exercise, there will be a higher pliability of muscles. Muscle pliability is how flexible the muscle is, and when the muscle is warm and full of blood, the pliability increases. The rate of nerve impulse transmission would increase as well during steady state exercise because the amount of nerve impulses are sent to the body and working muscles. This is because they increase. The muscles need to be told to work, and the rest of the body has to do what it normally does. The increase occurs because the body is not used to having the contractions that it is having at the moment. Energy system. ATP. I believe that the production of ATP would increase during steady state exercise. This usually occurs at the beginning of an event. This is because it is explosive and usually lasts for 1 to 3 seconds. Aerobic. I believe that the aerobic system would increase this because the maximum heart rate would be used. The aerobic system would be used because it lasts longer than 3 minutes. Also, there's no byproducts of this. It uses the glycogen stores along with other fatty stores which have come from the food intake into the body. These are already found within the body, so no extra effort is required to use these. Anaerobic glycolysis. The anaerobic glycolysis system works the most efficiently up to 1 minute. However, after this, it slowly drops off and is not effective at this point. This should be used towards the end and beginning of the event because it needs it to be a sharp impact. The mitochondria. The mitochondria are the powerhouse of the cell and contain all of the protein and energy within the cell. The mitochondria would respire more during steady state exercise and then begin to plateau. towards the middle stages of the exercise when they don't need to. The Krebs cycle. The Krebs cycle would increase during steady-state exercise. This is because carbon dioxide is produced along with hydrogen, which is crucial for the electron transport chain, which features next. The electron transport chain is important because it delivers hydrogen where it is needed and produces energy, which is crucial for the body to continue working at steady state during exercise. If the energy wasn't produced, then the body would not be able to perform at its highest level. Analysis of performance. Heart rate. According to the normative data tables, all three of the results don't match up with what I was expecting. This is because the normative data suggests a steady increase of the heart rate and then a plateau from 3 to 20 minutes. However, when you look at the data that I collected, you can clearly see that there is no steady increase of the heart rate. For example, it decreases, increases, and decreases and increases. The best results that I gained were Rachel's results here. This is because that you can clearly see a small plateau here, however, and also in Luke's. However, there is a decrease and increase, but also you can see that Rachel's heart rate was almost at 200. To me, this indicates that she was working in the wrong training zone, and because of this, there could have been many different reasons because of this. And the reason for this could have been that the equipment was faulty, and I could have been telling her to work harder. No, work harder because it was telling her not to. But however, her heart rate was up there. Luke does also show a sort of plateau. However, it is also incorrect as it just consistently increases, and he also was above the 157 training zone that we predicted for him. Billy's results are definitely an anomaly. This is because they are all over the place, and there is no clear plateau. I believe so they may have said take it easier, so his heart rate decreased, for example, after 6 minutes here, and then they said you're going too slow, increase here, and then decrease and increase again. My cardiovascular analysis. To measure the heart rate, I use the heart rate monitor and a Fitbit. This is to ensure the results are accurate. According to the normative data, the heart rate should steadily increase and then plateau after roughly 3 minutes, and then gradually drop off after exercise is finished. I discovered that there was an average decrease of 8 beats per minute across the 3 clients I tested. This is due to Rachel's decrease at the start. I believe that the equipment may have been faulty, which led to the results that I gained. Because of this, the clients may have been told to work harder or ease off. This means they're in the wrong target zone, which impacts the results. During the middle stages, 3 to 20 minutes, there was an increase of 45 beats per minute. This shows that there wasn't a plateau, which there should have been, and the clients hadn't, again, worked in training zone that I predicted for them. Rachel exceeded the target zone along with Luke and Billy. This again could have been due to the equipment. However, if you look at other data such as lactate levels, you can clearly see that not much lactic acid was being produced, so they must have been working anaerobically. This is different to what I predicted in my hypothesis because I did not expect a decrease. Here you can see in the breathing rate where I predicted a plateau. There was no plateau for Rachel, it fluctuates. Billy's is the most accurate results for me because it shows a small plateau, but still an increase. However, for Luke, it was a constant increase and then a small plateau at the end. I believe that because we used counting methods through the eyes, the results aren't very accurate, and to improve this, we could have used something else. However, the equipment for that is more expensive. Respiratory analysis. To measure the breathing rate, I observed my client's chest as they breathed and counted this. According to the normative data, the breathing rate should increase and then plateau around 3 minutes until the exercise is finished at roughly 20 minutes. At the beginning, there was an average increase of 15 breaths per minute. This is because the exercise had started and the body must react to the demand for oxygen. From 10 minutes to 18 minutes, there was a decrease of 5 breaths per minute. This is because the client was most likely tired and the body is reacting to that. Billy was an anomaly because it was considerably higher than the others and the normative data results. This can show that he was in the incorrect training zone because you can see here he was working at 63 beats per minute, breaths per minute, sorry, whereas Rachel was working at 16. The RPE scale. The RPE scale is a board scale where you can see how hard your client is working from their opinion. And here you can see that Rachel thought she was working harder than he was working harder. She was working as hard as she thought she was. However, her heart rate doesn't suggest this. O2 saturation. The O2 saturation also shows a clear plateau in Rachel's results and Luke's results and also Billy's results. This is what I predicted because there's more oxygen inside of their body. Lactate levels. Rachel's lactate levels do a backwards plateau and Billy's constantly decrease, whereas Luke's zigzag, which is not what we expected. We expected not much lactate. However, here you can see Luke's exceeded 20. I predicted that the main energy system would be the aerobic energy system. This is because any steady state exercise is submaximal. I use a blood lactate monitor and an O2 oximeter to measure how much lactic acid is in the blood. Lactic acid is a byproduct of anaerobic exercise and there was a lot of it, then it would have been clear my plants were working in the wrong training zone, which I believe they were.